In this tutorial, I am going to explain about the use of Hall sensor by using thingsio.ai cloud and esp32 module. So, what actually a Hall? Let us know what actually a Hall sensor is. A Hall effect sensor is a device that is used to measure the magnitude of a magnetic field. So, its output voltage is directly proportional to the magnetic field strength through it. The areas of application is of these Hall sensors are proximity sensing, positioning, speed detection, and current sensing applications. A Hall sensor, when it is combined with the threshold detection, it acts as a switch. So its common industrial applications are position sensing in automobile and direct current transformers, automotive fuel indicators, and keyboard switch. So this is the Hall sensor and it has 4 pins: D out, A out, ground, and a VCC pin. So the D out pin is used to read the digital values from the sensor, which is 1 with logic 1 or logic 0. So the A out reads the continuous or analogous values, and the ground and VCC is a voltage input pin. So the connections of this is given by the A out pin is connected to the VP pin of the esp32, and then the VCC is connected to the 3v3 and ground is connected to the ground of the esp32 pin respectively. So the IoT platform which I am using here is thingsio.ai. So in order to register, if you are new to the platform, you just have to register by clicking on this register button. The registration process is simple. So you have to give your name, your mail address, password, and the contact number. A verification mail will be sent and you can activate it by logging to the mail. So I'm just logging in as I have done previous projects, and then so here, in order to create a new project, you just have to click on the new project button and then give your project name. So the project name which I am giving is 5b. You can enter your own project name and then create the project. So the next thing is you have to give the device name. So I am giving the project device name as proximity, and then the device ID, which is a very crucial part. So the device ID is very important, as the values which you read from the sensor have to be sent to the cloud by using the device ID. So you just have to create and configure the device. So the parameter, you have to give the parameter. So the parameter which I am giving is a proximity, and then I am giving it as decimal. So you have to select your energy parameter and then update the device. So the cloud has some sample codes, so you can see the data is 0 here, as no data is being sent into the cloud. So the cloud has some sample codes. You can take the sample code and modify it according to your program. So I am copying the esp32 code here and then pasting it in my Arduino IDE and making some changes. So here the changes which you have to do is, so here the first change is you have to give your Wi-Fi name and then your Wi-Fi password. And the next thing is, so the program which we, we got from the cloud is of DHT11, which is used for temperature and humidity. So you have to just erase the program and write the new one for the proximity. So I have written the program according to the, and then I have, and then here we have to give the device ID. The device ID which I have got is here. So you have to copy it and then paste. So here you have to give the energy parameter which you mentioned in the device. So this is the parameter, and then you have to check the board. So here I am using the ESP32 module, and then you have to check since the and then you have to connect. So you can see here your COM port is now available. So and then the next thing is you have to upload the code into the sensor. So the problem with ESP32 which I faced is you have to manually erase the previously dumped program, and then in order to dump the new program you just have to click the enable button manually, so it doesn't do it automatically. So and then since the program is being uploaded into the board, we'll check for this. And now you can see that you can see here 200 OK, which means that your value is being sent into the cloud. And then you can see the hall measurement like 25, and then so we'll check if the data is being sent to the cloud or not. So here you can check your data in a bar graph representation, and then you can create your own custom graph by clicking on this, and then you can see here the values of your sensor. So you just have to save changes, and then your graph will be created. So with the graph you can analyze the use of the sensor, and you can use it in various applications. So you can check out the full tutorial in the instructables which I'll mention in the description box. Thank you.